Hello, this is Jacob. Today I'm making a video to show you guys um, how to build a GPT-o1 similar service using the open source stack. So I know o1 is very popular, and also like the GPT-o1 is quite expensive because of the self-reasoning, self-prompting. Um, so to make it more usable and to make this whole like self-reasoning or self-prompting um, more usable and be able to access my people that don't want to pay for GPT or GPT-o1 services. So here's the video that I might help, right? So in this video, I'm going to show you how to use MindSearch and Groq um, to build a o1 service, similar service. Um, and we're going to demo this on Colab, or you can actually use like any virtual machine, because Groq will offer the GPU, so you just use the endpoint of Groq. So this demo can be on any machine, like virtual boxes without GPU. Of course, you can test it a box with GPU. You can also try this on a local machine, any notebooks or your local machine as well. So hopefully this is something that would interest you. Um, Please follow through to the end of this video. So you basically will be able to see how to build a GPT-o1 similar service. That being said, let's get started. So um, basically, let's first go to the MindSearch GitHub repo, because I know some of you guys probably have not heard MindSearch. So MindSearch is an LLM-based multi-agent framework of web search engine like Perplexity.ai Pro and SearchGPT. SearchGPT is actually also a part of the OpenAI, so I think it's not released yet, but it's still like in the waiting list. Maybe they're testing something. MindSearch is a open source alternative to that. Perplexity is very popular, so it's web search based AI search. Um, so this is MindSearch. I have a few videos in this channel, so that you can also check that out, and then to see or get a feel of what MindSearch is and how that works. Um, of course, this will also cover that as well, but it's going to be tested on a open source model which hosted on Groq. So that's about MindSearch. Let's go to Groq. So there's another component that's going to come into play. Groq is a fast AI inferencing platform. So it basically hosts a lot of popular open source models. So people can just hop on the Groq platform and try that out. For this example, I can just go to Groq Cloud, and you will be able to basically have a lot of models try out, like Gma 2 and also the Llama 3, Llama 3.1. Uh, Basically, the 70 and 8B version both available. You can try Mistral AI's Mistral version. So there's a lot of the open source model. You can try that out. In this demo, we're gonna use the Llama 3.1 70B versatile. So this is one of the very popular ones that on Groq. Um, so and let's get started. Let's jump into the notebook to see how this works. Okay. So here's the Google Colab. Um, so it's just one notebook, and you can just use the same thing on your like Python script, or maybe just build something in the VirtualBox. It will be a similar process, but this video is really just um, to demo how this process works on the Colab. So which is should be easy. Um, so first we just make a directory. This will host all the logs that we use to debugging, and then we just do a git clone of the MindSearch repo, and then we just have to also update the requirements, because the MindSearch default requirements has some limitations. This will allow the MindSearch to work at its best. So just copy everything, dump it to a requirements file. Then you just do install all the dependencies, and then I think MindSearch somehow had issue with the notebook, so you have to also install this class registry dependency. So and that's all the dependencies you need for MindSearch. Then you have to update a few files in MindSearch, because right now we're using Groq as a dependency. Um, the MindSearch doesn't support Groq. Right? MindSearch just supports a couple of models. Like one of the models by default built by MindSearch itself is called intern LM. So that's one of the Bob models it supports, and then it also supports OpenAI GPT-4. So you can also use the OpenAI GPT-4. We're gonna use this as a entry point for the Groq, uh, and also supports Q1 and also like Intel LM Silicon. So as I said, so we're gonna use GPT-4 as an entry point for the Groq. So we're gonna wire up Groq inside GPT-4 interface. To do that, we just specify the model type because the Llama 3.1, 70B, versatile, and also we try to use the Open API key here. So it's basically we can get it from Groq's API keys. Just create one, and I use this one for demo first. I'll remove that after the demo. So let's go back to the notebook. So you also have to specify the API base. You have to use the full URL, the api.groq.com, OpenAI v1 chat completions, because Groq is actually built very compatible with OpenAI GPT endpoints, so which is awesome. So just use the Groq's API endpoints. So that's it. So for the models, you have to just update this GPT-4 model configuration. And let's continue. So we basically hard-coded all these configurations inside the model. You can also do this in the configuration file. You can specify a .environment to just specify this, and then they should also work. And then another thing we have to update is the Open API in the our agent. So MindSearch use its own sort of like a agent framework to wire up the model. So it's called our agent, and then basically OpenAI script is inside the our agent. So we have to update a couple of things. First, we have to update OpenAI API base. It should make it easy. You should actually also read from the configuration we saw earlier, but we just update it here. And also we try to update the logic that's actually reading the model type. So if you scroll down, a function is called generate request data. There's a model type, and basically it's going to checking like if the model type is a GPT or if it's internal LM or it's a Q1. If that's not inside, it's not among all these options, then they'll say, okay, model type is not supported. To fix that, we have to change that to use the llama. Right, so model type lowercase, if you start with llama, which we're using llama 70B, versatile on Groq, so that's why we have to add a check here. And if you use other models like Mixshow and also maybe Jima, then you basically just update it here, similar, right? And so all you have to do is to just update these two things, or maybe just one, just update this model type check. Then we have to install the supervisor because sometimes the notebook will shut down this server backend process. So to make it more stable, then you have to update supervisor. So this is to keep the backend service running. And we just need to configure a MindSearch service, just basically a program, which is what supervisors referring. So it's a program that is going to run as a backend service. So basically specify the directory, which is where the MindSearch hosted. Then we specify the command. So instead of using the default Intel LM server, we just specify the model we're using is GPT-4. So it's going to wire up the Groq backend. So, and then lastly, we just specify we want them to get also auto restart if somehow it's not working, and we just specify also the error logs and output logs. That's it for the supervisor configuration. Then we just restart the supervisor, so the supervisor is running, and we just check if the MindSearch service is gonna spin up. So it's running, so that means it's already spin up. So this is all the configuration you need for the MindSearch backend. So for the front end, there's two ways to do it. One is for the Streamlit, the other one is using the Gradle. So we're gonna demo both, but the first one we're gonna use just a Streamlit. So this is just a run command. We just try to run some bash script within the Python environment, and then we just check the if the port, this is a 8002 port, so that's where the backend MindSearch service runs. So we just check that is running. Then we just also can do a test. It's optional. You can test if the MindSearch backend is working. So they will show you some of the output. So then we basically set up the Groq. So Groq is going to expose the service that's running on a local notebook to the outside. So it's going to be make it public. And after that, we just grab the Groq token from your Groq console and then paste it here. So then you'll set up everything, and we can do a cat. So if it's working, after that, then we just do um, connect, right? Ungrow connect. So this will basically spin up a ungrow server, which is going to route the public traffic to your local notebook. So basically we just run that. So this gonna spin up the ungrow the Streamlit service on your A501. So that's gonna be a local host. So it's gonna expose that to the ungrow public instance. So and that's it. So this one is basically my Gradle script. So it's gonna spin up the Gradle. We're gonna see that in a bit. So let's go to the Streamlit MindSearch. So if you can see here, right? So this is basically the one that we just saw in the notebook D5B2. So here, so D5B2. So that's this Streamlit version of the MindSearch. So you can just search everything. We did this test before the recording. So basically what we're trying to do is just assume the laws of physics on Earth, and then small strawberry is put into a normal cup, and the cup is placed upside down table. Someone then takes the cup and puts it inside a microwave. Where's the strawberry now? Explain your reasoning step by step. So this is actually gonna run a similar process like GPT-01. So it basically it's start to think and self-prompting, uh, and to finally figure out the reason, right? Why um, where's the strawberry? To figure out why. So this is the process that's actually went through like first to figure out the question and what the question is about, what kind of things it's trying to check, right? So first it's going to check if the strawberry position after the cup flip, then it will figure out like object movement in a microwave, and so these are all the things that it's trying to check, right? It's self-prompting. So then the final response we'll get is this, right? The strawberry will like it to be on the table outside the cup. Here's the step-by-step reasoning. So this is gonna go through the reasoning similar to GPT-01, right? So and then in the summary, it will say, so here are the reasoning. You can read them through, and then in the summary, the strawberry will fall out of the cup when it's flipped upside down, and will remain on the table unaffected by microwave. So which is correct by common sense. There's a different answer though. If you search for perplexity, um, which is something, perplexity is very similar to MindSearch, as we mentioned earlier in this video. They actually have a little bit different answer. Feel free to read that also. It's a different, but it can make sense. It's not really like a common sense, but it can make sense. So let's go back to the MindSearch. So here's also like you can check the reasoning for each step. So it's very nice. You can basically play around with this if you follow through the script that I demoed in here. Another sample is for the Gradle, right? So if you just also do the same using the Gradle, using the script here, you'll basically see this interface, right? So you can search for like what are some of the most popular YouTubers. It's gonna help you basically bring up all these YouTubers. Sometimes because you searched before, it's gonna read from the cache. If it's not, then it'll basically go through that reasoning or the self-questioning, self-prompting process. it's RAG, basically it's RAG. Um, and then you basically look at the answer here. So, like similar question you can ask like, what are some of the popular AI YouTubers, or you can ask what's the weather look like in San Jose, California. So you can ask all those questions. It's gonna build a graph, a search graph like a graph RAG, and then they're gonna figure out what question to ask, what basically what prompting is gonna generate, and then step by step, it's gonna eventually figure out the answer. So, like if you can ask them to build a game like, um, for example, can you generate a Minesweeper for a game in HTML, CSS, JS? Yes, it can. So basically, it's gonna pump out all these CSS and JavaScript and HTML. So which is nice. Um, so that being said, hopefully this tutorial is helpful. If you have any issues, let's say sometimes it's gonna give you the right response. Just most likely it's because of the rate limit on the Groq, because it has a limit on per minute and a limit per day. So let's go to settings to check out the limits. So you can see that. So there's a lot of limits for a different model, like requests per minute is 30 minutes or 30 requests per minute, how many minutes per day, and tokens per minute. So you can check the model and also corresponding limit, and you can also check the logs. So for example, if something not working properly, oh, so rate limit exceeded. So just give you an example. If you sometimes you didn't get answer, or sometimes it broke in the middle of the RAG or self prompting, it might not get the exact right answer. So because of rate limit. So just keep that in mind also. That being said, hopefully this is helpful. So this is a open source alternative for the GPT-01. Hope you enjoyed this video. If you have any questions, please comment, subscribe, or like. So it will help me to make more video like this. Thank you so much, and see you in the next one.